TP-Link Omada is a smarter end-to-end cloud solution dedicated to business networking, integrating gateways, switches, access points, and more into a full software-defined networking solution. Omada provides 100% centralized cloud management to create a highly scalable network, all controlled from a single interface, anywhere, anytime. TP-Link Omada is specially designed for use in hospitality, education, retail, offices, and more, providing scenario-based products with diverse benefits. If you are interested in the TP-Link Omada solution, visit our website for more details. Today we'll introduce how to do a full configuration with TP-Link Omada products. As an example, we are going to build the wired and wireless network from scratch at our TP-Link office. We'll use ER605 as the router, TLSG3428MP as a PoE switch, and EAP610 as the access points. And we'll use the Omada hardware controller OC300 to control all these devices, and a PC to manage the OC300. As an alternative to the Omada hardware controller, you can use the Omada software controller, which you can download from our website, install directly on your PC, and set up similarly to the OC300 in our example. To build a network, we connect the WAN port of the router to the internet, and the LAN port of the router to the switch. Then we connect the EAP's OC300 and our PC to the PoE switch, and connect other wired clients to the switch as well. For security purposes, we want to divide the LAN network into different VLANs and IP segments based on departments in our office, such as the R&D department and marketing department. The requirements are as follows. 1. There are wired and wireless networks for each department. 2. Different departments cannot access each other, but both departments can access the internet. 3. Wi-Fi for both departments are applied to all the EAPs and cover the whole office. However, we'll distribute different sets of SSIDs and passwords to the staff in different departments, so that they'll connect to the corresponding VLAN. 4. All the devices are configured and monitored on a central platform OC300 in our example. To meet all the requirements, we'll take the following steps to set up our devices and network. Step 1. Log into the controller. Step 2. Adopt devices. Step 3. View dashboard and menus. Step 4. Set up a WAN. Step 5. Set up a LAN and VLANs. Step 6. Set up Wi-Fi. Step 7. Set up an ACL. Feel free to jump to any step you wish according to the timestamps in the video. Step 1. Log into the controller. To set up the network, first log into the Omada controller's webpage from the PC. As mentioned before, if you are using the software controller, after you run the software on your PC, the controller opens its own page automatically on the web browser. Or you can click Launch a Browser to manage the network. However, as we are using the hardware controller OC300, which gets its IP address from the DHCP server of the router, we don't know its IP address explicitly, but we can find it on the router's DHCP client list. Open the command line on the PC and enter ipconfig. Here we can find that default gateway is 192.168.0.1, which should be the IP address of the router. Launch a web browser and enter the IP address of the router. Enter the username and password to log into the router's webpage. Both the username and password are admin by default. Then go to Network, LAN, DHCP client list to find the IP address of OC300 according to its MAC address. Here the IP address is 192.168.0.213. Enter the IP address of OC300 to open the Omada controller's webpage. Click Let's Get Started. Enter TP-Link controller as a controller's name. Set the country and time zone, and select Office as a scenario. Then click Next. Select the devices which you want to adopt and manage through the controller. Here we have our router, switch, and EAPs on the list, so we'll select them all and click Next. Alternatively, you can skip this step and adopt your devices afterwards. This page is about configuring Wi-Fi, but we can get to that later, so we click Skip. On this page, enter the username and password for the administrator, and we'll use them to log into the controller afterwards. If you want to use your controller remotely, you can enable cloud access and bind your TP-Link ID to your controller. But we don't need it right now, so we'll skip this part. Click Next. This is a summary page of what we've done so far. Click Finish. Now we need to enter our username and password to log into the Omada controller. This page is an overview of the controller itself. This is the dashboard of our Omada controller. From the top right of the page, we know that we're at the default site. We can see how many devices there are in this site. Step 2. Adopt devices. From the sidebar on the left, go to Devices. Here we can see the current devices which are connected and adopted by the controller. If you didn't adopt your devices in the setup wizard, the status would be pending, and you should adopt them on this page. Click the checkmark buttons in the action column. If your devices don't appear on the list, check whether these devices are powered up and connected, and make sure that your controller has access to the devices via the network. If you have changed the password of a device, you need to enter the password when adopting the device. If you cannot adopt the device anyway, reset the device and then try again. Step 3. View dashboard and menus. From the sidebar on the left, we can go to the other pages. In Map, we can see how our devices are connected to each other. In Statistics, we can see the performance of our devices. In Clients, we can see the clients connected to the device. For example, we have 2 clients right now, namely our PC and OC300. On the Insights page, we can gain info about known clients, portal authorizations, and rogue APs. In Log, we can see what happened to our controller and devices, and whether there are alerts, events, or notifications. Step 4. Set up a WAN. Now we are going to set up a WAN for the router, which is the internet connection. Go to Settings. This is where we configure our network and devices. Go to Wired Networks, and then Internet. We need to select the connection type according to the requirements of our ISP. If you get a dynamic IP from your ISP, you should select Dynamic IP. Since we have a static IP from our ISP, we'll select the static IP and enter the IP address, subnet mask, default gateway, and DNS server provided by the ISP. Click Apply. Now that we have completed setting up a WAN, we are going to test whether we can connect to the internet. Open the command line and enter ping www.google.com. Here we received a reply from Google, which proves we have an internet connection. Step 5. Set up LAN and VLANs. Now we are going to set up a LAN, the local network, and VLANs. First, we are going to check the default LAN settings. Go to Wired Networks, and then go to LAN. There we can see the default LAN settings. The IP address is 192.168.0.1. The VLAN is VLAN 1, and the DHCP server is enabled. The DHCP server assigns the IP address to our PC and OC300, among other devices in VLAN 1. We could simply keep the default settings for LAN. Moreover, we want to divide the local network into 2 more VLANs and IP segments, namely VLAN 10 for the R&D department and VLAN 20 for the marketing department. The VLAN interfaces are 172.31.10.1 for VLAN 10 and 172.31.20.1 for VLAN 20. To create VLAN 10, click Create New LAN. Set the name as R&D. Select Interface, as we'll create an interface for this VLAN. Select all the LAN ports on the router, which should belong to the VLAN. Set the VLAN as VLAN 10, the gateway as 172.31.10.1, and the subnet as 24. Then click Update DHCP range, and we'll get the IP range for this VLAN. Keep the DHCP server enabled so that any client connected to this VLAN will get an IP address within the IP range automatically. Click Save. Similarly, we'll create VLAN 20 as well. Click Create New LAN, set the name as Marketing, select Interface, select all the LAN ports on the router, set the VLAN as VLAN 20, the gateway as 172.31.20.1, and the subnet as 24. Then click Update DHCP range and we'll get the IP range in this VLAN. Keep the DHCP server enabled. Click Save. Finally, we have LAN VLAN 1, R&D VLAN 10, and Marketing VLAN 20 on the list. To make the VLANs take effect, we have to create profiles during VLAN setup, and then apply the profiles to switch ports accordingly. Now we have port 13 connected to the router, port 10 and port 12 connected to the EAPs, port 1 and port 2 connected to the management PC and Omada controller in VLAN 1, port 4 and port 6 connected to clients in VLAN 10, port 18 and port 20 connected to clients in VLAN 20. To keep things in order, we designed the profiles and corresponding ports as the table below. Why should we design the profiles like this? Let's look how the native network tag networks and untagged networks work on these ports. For example, port 4 and 6 are connected to the clients in VLAN 10. We set R&D VLAN 10 as a native network so that traffic from the clients will be distributed in VLAN 10. We set the R&D VLAN 10 as an untagged network so that the wired clients can receive untagged packets from switch ports in VLAN 10, because the clients cannot deal with tagged packets. Ports 1, 2, 18, and 20 are similar. The basic principle is that when you connect a wired client like a PC to the switch port, use the native network and untagged networks to distribute its traffic to the corresponding VLAN. As for ports 10 and 12, they are connected to the EAPs. We set LAN VLAN 1 as the native network and untagged network, so that the EAPs can send and receive its own traffic in VLAN 1. We set R&D VLAN 10 and Marketing VLAN 20 as tagged networks to deal with the traffic from wireless clients. Those clients connect to the SSID in either VLAN 10 or VLAN 20. We'll set up the SSIDs later. So the traffic from wireless clients to switch ports is already tagged by the EAP. When the tagged traffic reaches the switch ports, we want the traffic to be distributed in VLAN 10 or VLAN 20 according to the tag. The basic principle is that when the switch port receives tagged traffic from devices like an EAP or another switch, use tag networks to distribute the tagged traffic to the corresponding VLAN. That explains why we designed the profiles for ports as they are. Now let's check the default port profiles. Go to Profile. There are already some default profiles on the list. They were automatically created by the controller according to your VLAN setup. Let's check whether the profiles meet our demands. As we wanted, the All profile has the LAN as a native network and untagged network, while R&D and Marketing are tagged networks. The LAN profile has LAN as both native network and untagged network. The R&D profile has R&D as the native network and untagged network. The Marketing profile has Marketing as the native network and untagged network. Now we have all the profiles that we need, namely All, LAN, R&D, and Marketing. If the default port profiles don't meet your needs, you can create new port profiles. Simply click the button and customize your own profile and set up its native network, tag networks, and untagged networks as you require. Now that we've prepared all the profiles, we are going to apply the profiles to switch ports according to our plan. Go to Switch Settings. We have our switch on the list. Click Edit. Let's take port 4 and port 6 as an example. We're going to bind the R&D profile to them. Select port 4 and port 6 on the port list, and then click Edit Selected. Select R&D as the profile and click Apply. Now the R&D profile is applied to port 4 and port 6. With this method, we'll apply the profiles to the switch ports according to our plan. That is, apply the All profile to ports 10, 12, and 13, the LAN profile to ports 1 and 2, the R&D profile to ports 4 and 6, and the marketing profile to ports 18 and 20. Now, we've completed setting up a LAN and VLANs. Let's check the results. 1. We have different VLANs and IP segments for different departments. For example, the wired clients which connect to the R&D department belong to VLAN 10 and automatically receive an IP address in the 172.31.10.0/24 subnet. 2. Clients in each VLAN can access the internet. Till now, clients in different VLANs can still access each other. That's because we have created the VLAN interface for each individual VLAN. By default, traffic can pass through the VLAN interfaces. 3. If we want to segregate departments from each other, we need to create ACL rules. After setting up Wi-Fi, we'll create ACL rules for wired and wireless networks together. Step 6. Set up Wi-Fi. We are going to set up Wi-Fi for our EAPs. In our example, we are going to create multi-SSIDs for different departments in different VLANs, namely R&D staff in VLAN 10 and marketing staff in VLAN 20. By default, Wi-Fi for different departments are applied to all the EAPs and cover the whole office. However, we'll distribute different sets of SSIDs and passwords to staff in different departments, so that they'll connect to the corresponding VLAN. Go to Wireless Networks. To create the SSID for R&D staff in VLAN 10, click Create New Wireless Network. Set the network name SSID as R&D staff. Enable both 2.4 GHz and 5 GHz Wi-Fi. Select WPA Personal as the security method and enter the security key, which is the password for the SSID. Then click Advanced Settings. Enable VLAN and set the VLAN ID as 10, which is a VLAN for the R&D department. Click Apply. Likewise, we'll create the SSID for marketing staff in VLAN 20. Click Create New Wireless Network. Set the network name SSID as marketing staff. Enable both 2.4 GHz and 5 GHz Wi-Fi. Select WPA Personal as the security method and enter the security key. Then click Advanced Settings. Enable VLAN and set the VLAN ID as 20, which is a VLAN for the marketing department. Click Apply. Let's check whether the Wi-Fi settings are applied to our EAP. Go to Devices and select the EAP. Then go to the Config tab and click WLAN. We can confirm that Wi-Fi settings are applied to the EAP. Now, we've completed setting up Wi-Fi. Let's check the results. 1. We have different SSIDs for different departments in different VLANs. For example, the wireless clients which connect to R&D staff belong to VLAN 10 and automatically receive an IP address in the 172.31.10.0/24 subnet. 2. Wi-Fi for each department applies to all the EAPs and covers the whole office. As long as the staff get the SSID and password for their department, they can connect their own devices to the Wi-Fi wherever they are. Step 7. Set up ACL. Clients in different VLANs can still access each other through the VLAN interfaces. Now we are going to create ACL rules to segregate VLANs, also departments, from each other. Go to Network Security, ACL, and then switch ACL. Click Create New Rule. Set the name as R&D and Marketing. Select Deny as the policy. Select All Protocols. Enable Bidirectional to make a reverse ACL rule automatically. Select R&D as a source and Marketing as a destination. The type is Network for both. This ACL rule will deny all the traffic and protocols between the source and destination. Select Ports as the binding type and bind the ACL rule to all ports. Click Apply. Now, we've completed setting up the ACL. Let's check the results. 1. Clients in each VLAN can still access the internet. but clients in different VLANs can no longer access each other due to the ACL rule we have created. 2. The ACL rule applies to the wireless clients as well as the wired clients. Finally, we've completed the setup and all the network requirements are met. Thank you.